All right, so let's go ahead and finally get started on this thing. Sorry for the little computer glitch error. We're doing section 3.6 and 4.1 today, and as much as 4.1 as we can get, maybe 4.2 if we're lucky. But here's the deal. I just want to remind everybody, I know there's a lot of work in this class to do, and this is just normal for a college algebra class, but you've got these quizzes are pre-section quizzes. They're supposed to be due by the time we come to class, but I always make them due the day that we actually cover the material. And then you got the homework, which is due usually about a week after we cover the material, 5 or so days after we cover the material. So you got homework certification stuff to do, as well as pre-section quizzes, what we call quizzes. Quizzes are to be done before class. So for every section, there's two concepts to be done. So I believe it's due tonight or something or other. 3.6 and 4.1 are actually due because that's the day that I'm covering this stuff. And 4.2 I think is not due until we get back, which will be Wednesday after fall break and stuff. So yeah. No, they do this percentage decrease. This is all on the Honk system that you lose 10% every day that you're late and stuff like that. And if you've got a really, really valid excuse, you can come by and talk to me about why you're late. Chemistry is not one of them. But in case you're, I'm just picking on you. If you have a valid excuse, you come by and see me. Oh, I had a chemistry test the other night and I just could not get the thing done on time or something or other. You see me and I can actually go back behind the system and get you back to full credit on that. All right. So, all right, so here we go. Yes, omitting section 3.5. We go 3.4, 3.6, 4.1. So, last time we just started talking about this is the idea of circles. And the circles is a standard formula called x minus h squared plus y minus k squared equals r squared. And the way it works is to actually be able to graph and understand a circle, you need two things. You got to have the center and you got to have the radius. The center of a circle is the point HK. And if you'll notice, HK is the center of a circle and R is the radius. But how your formula works is this. The formula is x minus h quantity squared plus y minus k quantity squared. So if you want to figure out what the center of the circle is, you got to work inside the parentheses. I got minus h, but so I see the number here, and I'm going to take the opposite to figure out what h is. And I got y minus k, so I see minus k, and I'll take the opposite of that to get the y coordinate k for the center. And remember, it's equal to r squared, so obviously I had to take the square root of the r squared to figure out what the radius is. And the radius should be a positive number. It's a distance. So on this particular problem, they're trying to mess you up. I've got x squared plus y squared equals 49. What is your center of this particular circle? Well, there's nothing inside the parentheses here. So the x coordinate or the h coordinate must be 0. And there's nothing inside the parentheses with the y squared. So the y coordinate must be 0. So the center of this point is 0, 0. R squared is equal to 49, making r equal to 7. So the center is 0, 0, and the radius is 7. What about B here? I've got x plus 1 quantity squared plus y minus 4 quantity squared equals 25. What is the center of my circle? Well, inside the parentheses, take the opposite. I got x plus 1, so the opposite of that would be negative 1. I got y minus 4, so the opposite of that would be 4. So my center would be negative 1, 4. The r squared part is equal to 25, so when I take the square root of both sides, that gives me the radius to be 5. Does that make sense? We did this one last time, just to remind you. I got x minus 4 quantity squared plus y plus 7 quantity squared equals 1. Inside the parentheses, take the opposite, so I got minus 4, so my center is going to be at x coordinate is 4, and the y coordinate is going to be negative 7. And r squared is equal to 1, so when I take the square root of both sides, I get r equals 1. So what about D over here? I got x squared plus y plus 9 squared is equal to 8. What is the center first? What is my center going to be? Well, remember, inside the parentheses, take the opposite, but I don't see anything inside the parentheses of the x squared. That makes the x coordinate what? 0. and I see a y plus 9, so inside the parentheses take the opposite, so the k coordinate would be negative 9. R squared equals 8, making, when I take the square root of both sides, r equals the square root of 8, or for those people that want to clean this up, 8 is what? 2 square roots of 2. Remember, 8 is 4 times 2. The square root of 4 is 2, so the 2 pops out front times 2. I will take it either way. Sometimes they'll ask you to clean up the square root just to let you know. But now, let's work the problems backwards. Now they're giving me similar information here. Given the equation, give the equation in standard form for the circles that has a center at 6, -3, and a radius of 8. Well, just remember, this is your h is 6, your k is -3, and you remember, and your r is going to be 8, and you got your formula, x minus h squared plus y minus k quantity squared equals r squared, and just plug in for h and k. So I'm left with x minus h is 6 squared plus y minus k is -3 quantity squared equals 8 squared. And of course, they want you to clean it up because they don't like minus negatives, you know, that type of thing here. So you got x minus 6 quantity squared plus y minus negative is plus 3 quantity squared equals 8 squared is 64. And there's my equation. And you can double check this. Remember, your center inside the parentheses, take the opposite. So I got x minus 6, so your h coordinate should be 6. I got y plus 3, so the opposite it would be k is -3. And the square root of 64 is 8, so definitely good to go. What about this one? The center is at the point 0, 13, and the radius is the square root of 8. Well, again, h is going to be 0, k is going to be 13, r is the square root of 8. Plugging into my standard formula, x minus h squared plus y minus k quantity squared equals r squared. H is 0. This will be x minus 0 squared plus y minus k is 13 quantity squared equals the square root of 8 squared. You want to clean it up, but what exactly is x minus 0? That's just x. So that's that x squared. There's nothing inside the parentheses. That's why your h coordinate is going to be 0. Plus y minus 13 squared equals, what is the square root of 8 squared when you clean it up? Square roots and squares cancel. You're left with 8. And that's your standard form of an equation of a circle. So, how can they mess you up with this stuff? Well, they can mess you up by one, not giving you all the parts. I mean, all you need for a circle is two things, a center and a radius. So how can they mess you up? They can mess you up by making you have to go find these things. Let me show you. Find the equation of a circle, that was my big directions, with the diameter at the points, the endpoints of the diameter at the point 410 and 03. All right, what I need to have an equation of a circle is the center and the radius. But I've got not the radius, I've got the diameter. So if you actually think about a circle, I've got a circle here, and I've got a point on one side going through the center, and a point on the other side. But if I got the points on the diameter, what's going to make my center? The center is going to be the midpoint. So you actually have to outthink these problems here. So I need to figure out what the midpoint of these problems is. So you remember your midpoint formula. The midpoint is x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. x1 is going to be 4, y1 is going to be 10, x2 is going to be 0, y2 is going to be 3. So my midpoint would be 4 plus 0 divided by 2, comma, 10 plus 3 divided by 2. So I get, we can do some math in our head, 4 plus 0 is 4 divided by 2 is 2, comma, 10 plus 3, that's nice, 13 divided by 2, 13 halves. And leave it as a fraction. Typically, that's how our computer system wants it. So that is the midpoint, but the midpoint is the center. So I've just discovered what my h and k are going to be. But here's the other part. The other thing that I need for a circle is the radius. The radius is the distance from the center to one of your outside points. But the key to this is it's a distance. So the radius distance would, because it's a distance, I got to use the distance formula. See previous section. That would be the square root of x2 minus x1 squared plus y2 minus y1 squared. But I want the radius distance, so I'm going to use my center, which I just discovered, and one of my endpoints. Which ones do I like? I got two endpoints. I can use the point 410 or the point 03. It won't matter. Which one should you use? The smallest one, which would be 03. Less chance for screwing it up when you plug numbers into the formula and you've got to subtract 0 or whatever. Just watching the careless error. It honestly doesn't matter. You could use the 410 point if you want to. So my distance, r, is going to be the square root of x2 minus x1. I'm going to use this point right here. So it'll be 2 minus 0, just do it in order, squared plus 13 halves minus 3 quantity squared. Applying my distance formula to it. Does that make sense? All right. So, r is equal to the square root of, let's clean it up, 2 minus 0, well, that's pretty much 2 squared, plus, what is 13 halves? Now, 13 halves is what? 11, that's going to be 5, 6, 6 and a half minus 3, 13 halves minus 3 is 3 and a half, right. So this is 6 and a half minus 3, which is 3 and a half. But let's go fractions on this to really impress the computer here. So that is 7 halves, 3 and a half squared. So now we got a square. So this is the square root of, well, what exactly is 2 squared? 4 plus, what is 7 halves squared? Well, because it's strict multiplication division, I can basically distribute the power. Square the top and square the bottom. Squaring 7 is 49. Squaring 2, I get 4. So r is equal to the square root of, I'm just going to add these guys, and since it's fractions, I'm going to use my calculator here. 4 plus 49 fourths. 16.25, but let's go ahead and make it a fraction. That is 65 fourths. Okay, so it's a crappy fraction with a crappy square root. Don't worry about it. What did they want us to have? They wanted us to find the equation of the circle. X minus h squared plus y minus k squared equals r squared. So at least the square root will go away. Plug this stuff in. I get x minus 2 squared plus y minus 13 halves squared equals the square root of 65 fourths squared. So now, plugging it in and cleaning it up, I get the standard form of the equation of a circle is x minus 2 squared plus y minus 13 halves squared equals the square root of 65 fourths squared. The square root and the square cancel. You just left with 65 fourths. So what I'm telling you is prepare yourself for awful fractions, but that's okay. We can handle fractions. Just if you need it, use your fraction button on your calculator, but watch the careless errors. Does that make sense? Questions? Now, how bad can they make it? Look at the next section. The last one was bad, but you just had to jump through a bunch of hoops with midpoint formula and distance formula. They love those. The other one is this. Now we had the standard form of an equation of a circle, x minus h squared plus y minus k squared equals r squared. Now we have the general form of an equation of a circle, x squared plus y squared plus dx plus ey plus f equals 0. Okay? And they want you to standardly put the equation of a circle in standard form. We like the standard form, not the general form. The general form, I can't really tell you anything about the problem here. x squared plus y squared plus dx plus ey plus f equals 0. But when it's in the standard form, and just getting familiar with this, the standard form of x minus h squared plus y minus k squared equals r squared, this is the form that you get to read off data. The center, you can read it off as hk, take the opposite, and r is the radius. So all I had to do was take the square root of the r squared there and get my radius. So the question is, how in the world am I going to take this general form and turn it into standard form? And the real trick is right there in your directions. What do you got to do? Complete the square. This x minus h quantity squared plus y minus k quantity squared, these are perfect squares. So, step one. So I wrote these things out with little bullet points, but they're steps. Step number one. The first thing you want to do is this. Group together like terms. Your x's put them together, your y's put them together, and your constant there. So I'm going to group this stuff together. I got x squared, I'm going to put my other x term, plus 8x. So I'm just rearranging this stuff. Leave a little space. Plus y squared, plus 4y, leave a little space, plus 16 equals 0. Okay? All I did was group together like terms. I put my x's together, plus, I put my y's together, plus, I left my constant. Step two, move the constant to the other side. You're completing the square on the variables. So I'm going to, step two, move the constant to the other side. I'm going to subtract 16 from both sides. That gives me x squared plus 8x, leave a little space, plus y squared plus 4y, leave a little space, equals negative 16. Now we're going to complete the square. But there are two square terms in this stuff. You've got x squares and you got y squares. So I got to complete the square twice. One time for the x's and one time for the y's. But remember, how do you complete the square? You take 1/2 the b term and you square it. And remember, what I do to one side of the equation, I do to the other. And you add this number to both sides. Add to both sides. Add both sides. So, what is my b term with the x's? I got x squared plus 8x. What's my b term? 8. So we're going to take half of 8 and square it. What's half of 8? 4. What's 4 squared? 16. 16 is the magic number that completes the squares with the x's. I took my b term is 8. To complete the square, you take half the coefficient in front of the x, half of 8, which is 4, squared. 4 squared is 16. And here it is. I'm going to add 16 right there to the x's. So I've basically unbalanced my equation. But what I do to one side, I'm going to do to the other. I'm going to add 16 to one side, and I'm going to add 16 to the other. Now it's back to being balanced. What I do to one side, I do to the other. To complete the square, you take half the coefficient in front of the single variable and square it. Half of 8 is 4, squared is 16. Now I've got to complete the square on the y's. I've got y squared plus 4y. What is my b term? Again, I'm going to take half what I call the b term. I'm going to square it. I'm going to take half times my b term here would be 4 squared. What's half of 4? 2 squared is what? 4. The magic number that completes the square on the y's is 4. I'm going to add 4 to the y terms, and I'm going to add 4 to the other side constant. What I do to one side, I do to the other. Now, here we go. Now, this third step is pretty much your final step to get it into standard form, is you're going to factor. Factor the x terms. Okay? Factor the x terms. So I've got x squared plus 8x plus 16. So let me write it down here. X squared plus 8x plus 16 plus y squared plus 4y plus 4 equals negative 16 plus 16 plus 4. And I'm going to blow it up over here so you guys can see it. Now I'm going to complete the square on the x's. Remember, it's a perfect square. So how does x squared plus 8x plus 16 going to factor? X plus 4 times x plus 4, aka x plus 4 squared, plus How do the y squared plus 4y plus 4 factors? It always factors perfectly. Y, what times what is 4 that adds up to be 4? 2 and 2, plus plus. So I get y plus 2 squared equals, add up your constants. Negative 16 plus 16 cancels, plus 4 is 4, equals 4. And that has got my form, just changing the form from general form to standard form. Now to answer the question, please tell me what is my center and what is my radius? Very good. Inside the parentheses, take the opposite. So for the x-coordinate, I got negative 4. And for the y-coordinate, I got negative 2. R squared is equal to 4. So when I take the square root of both sides, that gets r equals 2. And I answered their questions. What's my center? What? Negative 4, negative 2. What is my radius? 2. Does that make sense? Complete the square. Something they love to do with this stuff. All right? So, we've got lots of problems for you to practice on completing the square. Here we go. Practice this one. X squared plus y squared minus 6y minus 7 equals 0. All right. Remember what I said. Step 1. When you've got the general form of equation of a circle, you've got to complete the square to get it in the standard form so you can read off the information you need so you can graph it or do whatever you have to do to it. So, first thing I want to do in completing square is group together like terms. Get my x terms together, plus get my y terms together, and then move my constant to the other side. Look at this problem. What kind of x terms you got here? I've only got one. X squared. Well, put it there by himself, separate him. Plus, look at your y terms. I got y squared minus 6y, leave a little space, equals, move the constant to the other side. Equals 7. 0 plus 7 is 7. Now, completing the square. You take 1/2 the b term and square it. But you don't have to square the terms on the x's because there is no b term. It's 0 actually. So this is already perfectly squared. It's x squared. The only term that actually has a b term is the y's. What is my b term? So I'm going to take 1/2 of negative 6 and I'm going to square it to complete the square. What's half of negative 6? Negative 3. What is negative 3 quantity squared? 9. So I get 9. That's my magic number. So what I do to one side, add 9. I do to the other, add 9. And then I'm going to factor. X squared is pretty much set. X squared, because there's nothing to factor out of it. Plus, I've got y squared minus 6y plus 9. How is that going to factor? What times what is 9 that adds up to be negative 6? Negative 3, negative 3. You've got to have the same sign. So remember, it's a perfect square. They'll be exactly the same. Equals, and now I've got to add these two numbers together. What is 9 plus 7? 7 plus 9 is 16. So that gives me x squared plus y minus 3 squared equals 16. This is the form in the form of a circle in standard form. But of course, they're going to want you to read off the data. So please tell me what is my center and what is my radius. Very good. Remember, what's inside the parentheses and take the opposite, but there's nothing inside the parentheses on the x, so therefore the x coordinate has to be 0. The y coordinate, I got y minus 3, so I see that take the opposite, so the y coordinate is going to be 3. I've got r squared being equal to 16. That forces r to be equal to 4. And there's my answer. The center is 0, 3. The radius is 4. If they ever ask you to graph the circle, how do you graph the circle? Graph it. First, find your center. What's your center? 0, 3. X is 0, y is 3. 1, 2, 3. Put a dot there. Label them. C for center. What's my radius? 4. I'm going to go the points of the compass. I'm going to go north, south, east, and west, 4 units. So I'm going to go up 4. 1, 2, 3, 4. Put an X. I'm going to go down 4. 1, 2, 3, 4. Put an X. I'm going to go right 4. 1, 2, 3, 4. Put an X right across from the center. And go from the center left 4. 1, 2, 3, 4. Put an X. And then I'm going to connect my X dots. It's a circle, so it looks like that. And there's my graph of the equation of a circle. So to graph a circle, all you need is that center and the radius. You just take this, plot the center, and then go north, south, east, west, up, down, left, right, that many units for the radius, and then connect your outer points. But you know, those were nice problems for the most part. How can they mess you up? Give you fractions. Try this guy. I want you to figure out what the center and radius is of this circle. X squared plus y squared minus x minus y minus 2 equals 0. All right, well, it's clearly in general form, so I want to put it in standard form. So I'm going to group together my x's. I got x squared minus x, leave a little space, plus y squared minus y, leave a little space. And I'm going to move my constant always to the other side. 0 plus 2 is 2. Now let's complete the square. To complete the square, just to remind you, trying to drum it into your head, you take 1/2 times the b term. And you square it, and you add to both sides. The b term comes from the quadratic formula. It's the coefficient in front of the single variable. What's the b term in this problem for the x's? -1. So you're going to take 1/2 of -1 and you're going to square it. What's 1/2 times -1? -1/2. But what is -1/2 squared? What -1/2 times a -1/2? Negative times negative positive. 1/2 times 1/2 is a 4. Just square the top over square the bottom. So there's my magic number. That's right, it's a fraction. So I'm going to add 1/4 to both sides. The nice thing about this problem is the y terms work the same way, because it's 1/2 times the b term squared. But again, that'll be 1/2. My b term in this for the y's is also -1 squared. So 1/2 times -1 is -1/2. Quantity squared is equal to 1/4. So once again, I'm going to add 1/4 to both sides. What I do to one side, I do to the other. Now, cleaning this guy up, this is going to give you, well, let's write it out first. X squared minus x plus 1/4 plus y squared minus y plus 1/4 equals, what is 2 plus 1/4 plus 1/4? 1/4 plus 1/4 is 2/4 or 1/2. This is 2.5. Does that make sense? 1/4 plus 1/4 is 1/2 plus 2 is 2.5, which is also known as 5/2. But now let us factor this guy. How does x squared minus x plus 1/4 factor? Remember, it's a perfect square. It's going to be the same thing. X, what times what makes 1/4? 1/2 times 1/2, and now all you got to do is figure out what sign it's got to be. Is it plus or minus? Well, the back term is always a plus. Since the middle term's a minus, both terms will be minuses. Plus, the same idea on the y's. I got y times y. What times what is 1/4? It had to be 1/2 and 1/2, and since the middle term's a minus, both terms have to be minus. Equals, the cleaned up fraction version, 5/2. So this gives me x minus 1/2 squared plus y minus 1/2 squared equals 5/2. There is the equation of my circle with the great fractions written in standard form. So now, from this problem, please read it off and tell me what is my center point and what is my radius. What's my center? Inside parentheses, take the opposite, 1/2, 1/2, 1/2 for the x, 1/2 for the y's. The radius is going to be what? Not very nice. R squared is equal to 5/2. You take the square root of both sides, and there's not much on cleaning that up. I guess I could rationalize it, but I don't think it matters. It's going to be the square root of 5/2. Does that make sense? Did I lose you anywhere? Okay. Try this next problem. X squared plus y squared plus 6y, I'm sorry, plus 6x plus 5 equals 0. Mission, find the center, find the radius. It's clearly in, again, general form, not standard form. So I'm going to rewrite this guy, grouping my x's together, plus, grouping my y's together, equal, move the constant to the side. Move the constant, I'm going to subtract 5. This will give me x squared, put the other x term with it, plus 6x, plus y squared, there are no more y terms, equals, the 5 moves to the other side, makes it equal to negative 5. To complete the square, there are no b terms on the y, so you've already got it completely squared, y squared, you're good to go. I need to complete the square on the x's. So I'm once again going to have 1/2 times what I call the b term squared. 1/2 of 6 squared, half times 6 is 3, squared makes it 9. So the magic number to complete the square is 9. So I'm going to add 9 to both sides. What I did to one side, I did the other. This gives me x squared plus 6x plus 9 plus y squared equals negative 5 plus 9, which is 4. Now the x's are going to factor. How do they factor? What times what is 9? 3 and 3, and because they're both plus, I got to have a plus here. So this gives me x plus 3 squared plus y squared equals 4. There is the answer when they ask you what is the, quote, standard form of the equation of a circle. What is the center? Very good. Negative 3, 0. What is my radius? 2. Because remind you, the formula is r squared. So r squared equals 4. That implies that r equals 2. Does that make sense? All right. Moving on into section 4.1. Chapter 4 is about analyzing the concept of relations and functions. Okay? A relation is nothing but a set of ordered pairs, x and y's. Traditionally, x is called the domain, y is called the range. Now, a function is a special type of relation. A function is a correspondence from one set, the domain, to another. I think the O is missing in that thing somewhere. Okay? Another set, the range, such that the element in the domain corresponds to exactly one element in the range. So how do I tell when I have a function or not? Well, you got to make sure that any given element in the domain can only map to or be paired up with exactly one element in the range. Okay? It could be the same element in the range. We don't care about the range. But one element in the domain can only map to one element in the range. You can't have one element in the domain going to two different elements in the range. That's not allowed. So, here's the deal. Example. And we try to come up with interesting examples to impress you guys, make you thirsty or whatever. Here's an example. Determine whether each of the following is an example of a function or not. All right. So, we've all played around with the vending machines outside and stuff like that. And how many times have you ever put in a coin, put in, I don't know, several coins these days, putting in, I don't know, $1, $1.50, $14 at, some kind of event like NASCAR, or going over to King's Dominion, or some other Carowinds or something like that. And of course, when you go to some kind of a special event, they seem to want to charge you an arm and a leg for those drinks, where anybody else it cost you $1 at a convenience store or whatever. But here's the deal. You put your money in. There's a Coke button. If I push Coke, guess what pops out? Coke. Got a Diet Coke. Push the money, push the Diet Coke pops out. Push the Sprite button, Sprite pops out. Push the Fanta button, Fanta orange comes out. Push the water button. Why you're paying so much for water, I don't know, but water pops out, it's fine. Is this going to make a function? Does this machine define a function? So that's the question. Function, question mark. The answer is yes. This thing is a function. And here's your domain, here's the range, what we're getting out of it. But let's take a look at problem number 2 over here. Here's the machine. You put your money in, you push the Coke button, and guess what? Coke pops out. What a surprise. But this is a surprise that's happened to me more than once. I put my money in, I put the Sprite button, and guess what popped out? Something else. Coke or Sprite pops out. Well, if a Sprite pops out, I'm fine with that. But when the Coke pops out and I ordered Sprite, I'm not real happy about that. Diet Coke had the same problem here. You push the Diet Coke button, Coke or Diet Coke pops out. Well, honestly, tastes better if the Coke popped out, but whatever. Coke or Diet Coke could pop out, and that's the issue there. Some people want that Diet Coke. They like that Diet Coke taste, and therefore they push the Diet Coke button and they got real Coke. All right, you push the Sprite button, Sprite pops out. Push the Fanta button, Fanta pops out. Is this going to make a function, yes or no? So the question is function, question mark. The answer is no. Why is it not a function? I've got a single domain, but like for example, Sprite, my domain is Sprite, but I got 2 different Y components popping out with that pushing of the Sprite button. Does that make sense? I got either Coke or Sprite coming out. I got 2 different Y coordinates ranges for the same X coordinate. All right, come down here. Does this make a function? Yes or no? You got 2 different Coke buttons, but that's all right. When you push the Coke button, the single Coke button pops out. Coke pops out. Diet Coke goes to Diet Coke. Sprite goes to Sprite. You got another Sprite button. Fine, they must have lots of people liking Sprite and Coke. So they put another button for Sprite, but Sprite pops out, Fanta pops out, and water pops out. So is this going to make a function? Yes. Even though we have 2 different Coke buttons, it's really the same Coke button, and most important, the same Y coordinate pops out. There can only be one Y coordinate for any X coordinate. So the question is on function, the answer would be yes. But again, over here, here's your problem. That top Coke button seems to work. When I push Coke, I get Coke. But the bottom Coke button doesn't always work. Sometimes you get the Coke, or you get really mad when you want Coke and you actually end up getting Diet Coke. Okay? Diet Coke really does work. You get Diet Coke. Sprite, you get Sprite, but they got another Sprite button, but that's another problem because sometimes you get Sprite, sometimes the Fanta pops out. Fanta pops out the Fanta, and the water pops out the water. So my question is this going to make a function? No. And the reason why is because this Coke button actually maps Coke to Coke, but it also maps Coke to the Diet Coke, which is you can only get one value in your range. So this does not make a function. So instead of the Coke machines, let's try it over here. I got the points 1, 1, 3, 2, and 5, 3. Just look at this relation. Is this thing going to make a function? Yes or no? Yes. 1 goes to 1, 3 goes to 2, and 5 goes to 3. Every X gets to map to a single and a different, in this case, Y coordinate. So this is a function, and I just want you to tell me to make sure you guys understand. If I ask for what is the domain of this problem and what is the range, please tell me what you get. What is the domain? Typically we're using set notation here. What is the domain of this problem? 1, 3, and 5. It's the X coordinates. What is the range? 1, 2, and 3. It's the Y coordinates. Does that make sense? Domain range. But is this a function? Function, question mark? Yes. This is definitely a function. 1X maps to 1Y. What about this guy over here? Number 6. I got the points 1, 1, 2, 4, 3, -5, and 2, -4. Does this make a function? I hear yeses and I hear nos. Well, which one is it? Well, if those people are saying no, you got to tell me why.
Because the first time when you plug in 2, you get 4, and the second time when you plug in 2, you got -4.
Very good. You've got the same X coordinate, 2, but you're mapping it to 2 different Y coordinates. Because you went from 2 to 4, and then you turned around and plotted 2 again and went to -4. Remember your definition of function. For any x in the domain, you can only have one element being mapped to it in the range. We got two different y coordinates in the range being mapped to it. So this is called, is this a function? No, this is not a function. When it's not a function, we just call it the general term called a relation. This thing's a relation. What about this one? X squared plus 2y equals 0. All of a sudden, they started throwing equations at you. Is this equation, x squared plus 2y equals 0, going to give me a function? Yes or no? Well, why? Okay, so it's a parabola. When you graph it, I think it's going to end up being an upside down parabola, but who cares? What's the deal here? Well, that's down here. We're up here. We can't go down here to grab stuff when we're up here.
Well, if you plug in whatever x you plug in, like you're gonna get a different y.
All right, so that's the key right there. Don't worry, we're about to get to the next section. You're right, but what they wanted you to do this problem was this. To figure out when you have an equation, whether you have a function or not, solve for y, solve for the range, solve for the y variable. If I want to solve for y, I would subtract x squared from both sides. That gives me 2y equals negative x squared. And then I would divide by 2 on both sides. And when I do that, I get y equals negative x squared divided by 2. Now you've got to start looking at, when I plug in numbers into this thing, am I going to plug in two different, if I'm going to plug in the same x value, will I possibly get two different y coordinates? So if you start plotting points on this guy, what kind of numbers can you plug in for x? Well, I can plug in negative numbers because I can square it to make it negative and divide by 2. I can plug in 0. I can plug in positive numbers. So get a sporadic mesh of a bunch of different kind of numbers. I'm going to plug in negative 2, negative 1, 0, 1, and 2. Couple of negatives just to check it out, 0, and I'm going to plug in a couple of positives. Let's see what we get. Negative 2, watch your math. Negative 2 quantity squared is equal to what? Negative 2 quantity squared, 4. With a negative in front of that makes it negative 4. Divided by 2 makes it negative 2. Try negative 1. Negative 1 squared, order of operation, you do the exponent first. Negative 1 squared, negative 1 times negative 1 is positive 1. But then negate that, the negative in front of that makes it back to negative 1 divided by 2 makes it negative 1/2. Plug in 0. 0 squared is 0, negative 0, still 0. Divided by 2 is still 0. So I go through the origin, 0, 0. 1 squared is 1, negative that would be negative. That would be negative 1/2. 2 squared is 4, negative that, negative 4 divided by 2 is negative 2. Does this make a function? Now remember, every x has to map to a single y coordinate. We don't care about the y coordinates. The y coordinates can be the same or they can be different. There's no restriction on y coordinates. It's the x coordinates can only map to one y coordinate. They can map to the same y coordinate for all we care. We don't care about that. We just care about one x gets only mapped once. Negative 2 gets mapped once, you get negative 2. Negative 1 gets mapped once, you get negative 1/2. 0 gets mapped once, you get 0. 1 only gets mapped once. You get back to negative 1/2 again, but we don't care about the y coordinates. The x's are just being mapped one time. So this thing is a function. Yes, for function. However, watch this guy. Number 8 over here is this. X squared plus y squared equals 1. X squared plus y squared equals 1. I want you to solve for y. How would you solve for y on this thing? And you would figure out why this one's going to have a problem. I would subtract x squared from both sides. That cancels. That leaves me with y squared equals 1 minus x squared. Now what would you do to solve for y? Take square root of both sides. That gives you y equals the square root of 1 minus x squared. However, right here is where most students will screw this problem up. They would try to simplify this. Clearly, the square root of 1 minus x squared is the square root of 1 minus the square root of x squared, which would be like 1 minus x, right? Wrong. You can't break up radicals under addition, subtraction. You can only break them up under strict multiplication, division. Because there's a minus right in the middle of this thing, you can't clean up this radical. This is the best I can do. But here's one other spot to this thing. How did I end up solving for y? I had to take the square root of both sides, right? And when I introduce a square root, or you introduce a square root into a problem, you got two options. What are my two options on square roots? Plus or minus. And I don't know which one I want, so I have to put plus or minus on any kind of even radical. Does that make sense? So, and when you start to try plotting points on this, you're going to see where your issues are going to come in at. So, let's plot some points here. X, Y, let's plug in, I don't know, all I really need to do is plug in 0, and you're going to see a problem here. Plug in 0 in this thing. 0 squared is 0. 1 minus 0 is 1. What's the square root of 1? 1. But I'm going to get the positive square root, which will be 1. I'm also going to get the negative square root, which will be negative 1. So 0 officially maps to 1 and negative 1. And there's my problem. I got the same x coordinate map into two different y coordinates. This guy is not a function. But there is an easier way to do this stuff, but you need to be familiar with manipulation of the equations. The easier way is the way we always kind of give a visual for this stuff, and that is this, something called the vertical line test. The vertical line test for functions. If any vertical line intersects a graph at more than once, you intersect at more than one spot, then the graph is not a function. So, here we go. Take a look at these guys. This is the equation of a line. The old classic y equals mx plus b stuff we studied last time. Is y equals mx plus b stuff a function? Well, take any vertical line. It doesn't matter which vertical line you choose. Any vertical line. How many times do you intersect this graph? Just once. If you only intersect it once, it is a function. So by the vertical line test, this implies we have a function. What about a circle, like what this guy is? This was x squared plus y squared equals 1. This is the equation of a circle centered at the origin, 0, 0. Radius is 1. R squared is 1, making r equal to 1. Is the equation of a circle, does that make a function? Any vertical line will actually intersect the graph at what? 2 spots, which means it is not a function. What about a parabola, which is what we were playing with earlier when I solved for y and got negative x squared over 2. Whether the parabola is going u up or u down, it doesn't matter in terms of uing up or uing down. So this problem or this problem over here, when you graphed it, what about a vertical line? Vertical line will only intersect a traditional parabola u-shaped up, u-shaped down. How many spots? 1 spot only, which means it is a function. This one's a function. What about a polynomial? Got a bunch of loops on this thing, but it's not looping back on itself, so any vertical line only intersects this function at once. So this one is a function. What about the famous 1 over x function? Oh, screw that up. 1 over x relation. Is it a function? Well, there it is. I'm going to put the other side. This is the graph of y equals 1 over x. Does this thing make a function? See, 0 is not defined, so we're skipping over 0, but where it is defined, when you graph it, how many places does a vertical line intersect? Once, which makes this a function. However, back to parabolas, if I happen to have a parabola and I turn it on its side, is it going to make a function now? When you turn it on its side, a vertical line will intersect it twice, and which means it is not a function. Does that make sense? Did I lose you guys anywhere? Vertical line test. So, honestly, back over here, I mean, it's interesting to be able to do this stuff, but you should always have in the back pocket the vertical line test. So if I go back here and clear off the old graphs and take this particular function and graph it, which was negative x squared divided by 2, and do a zoom 6 on it, you will notice that it's an upside down parabola, and any vertical line will only intersect the thing once. However, when I graph this guy by hand, a circle, it will violate the vertical line test and therefore tell you that it is not a function. So graphing it is always the easiest way to tell when you have a function or not. Again, reinforcing the ideas, so let's make it official, the concept of domain and range. Domain is the input or the x values, i.e. all the values of x that I may plug into a function. And the range are the outputs, the y values, all the values of y that I can plug, that the function can attain. So when I'm trying to figure out the domain, typically you can look at the function, because right now, and we're going to add to this list as we go through the class and add more and more function stuff here, but for right now, there's two major problems that you guys have with math. You can't divide by what number? 0. And you can't take the square root or an even root of what kind of numbers? Negative numbers. Those would be violating the functional aspect of, or the definition of these functions. You can't divide by 0, and you can't take the square root or even root of a negative number. Other than that, your domain is going to be all real numbers. You can plug anything you want to in this stuff. But if you have fractions or you have radicals, you've got to be careful. All right? But when I'm after the domain and range, we're trying to give you this visual perspective. So we've got these graphs here. And I want to know what the domain and range is for each one of these guys. All right? So I've got the same picture here. But with the domain, I'm after the x values. So when I'm looking for the domain, you look at the x-axis and figure out where your graph is at. So I'm going to put some numbers on this thing. I'm going to put this one to be negative 3 here and positive 3 there. And I'm going to graph this one down here. This will be like negative 2, and this would be like 5. I'm just making up numbers and putting them on here so we got something to deal with in terms of the domain and range. When they ask you what the domain is, you look at the x-coordinates. Take the graph and kind of mash it onto the x-axis for the domain. What numbers do you hit on the domain? I hit negative 3 and 3, but you see it, 3 is an open circle, right? So that will translate over to an open circle here. But over at negative 3, that was a filled-in circle, so that would translate to a filled-in circle. Filled-in circle means include, open circle means exclude. Bracket means include, parenthesis means exclude. So what is my domain in interval notation? Bracket, negative 3, comma, 3, what? Parentheses. Does that make sense? Well, these will be the same numbers over here. Here's negative 3, 3, negative 2, and 5 up here. But when they ask about the range, it's the only time, listen to my words, it's the only time that I really analyze the y-axis on a graph. We're going to be doing lots of things with graphs. We're going to figure out what the domain is. We're going to look at the range. We're going to look at the intervals of increase, where it's going up, intervals of decrease, where it's going down, intervals where it's constant. And every one of these times it says intervals, 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 you always describe a graph through its x-axis or its domain. The only time I ever use the y-axis is with one word. What's the range? So you take this graph right here, and you take the graph and you mash it onto the y-axis to figure out where the graph is at. And look at the y numbers. Because it's this closed-in circle there, it'll be a closed-in circle here. The graph runs all the way up to 5. But at 5, there's an open circle, so match it to the open circle at 5 on the y-axis. So you read it from bottom to top. The range would be bracket, negative 2, comma, 5, parentheses. It's the only time I use the y-axis to be able to describe something about the function. Yes, ma'am?
But like on like a quiz or a test or something, are the points going to be given to us, or are we going to have to make
No, I'm going to be giving you the points, or we're going to put it on some kind of interesting grid system where you can count them off. We made up this stuff, so I made it up kind of quickly, and I didn't put coordinates on there. So every instructor who's using these notes and stuff get to make up their own numbers and play with it. But it's okay. It's the same idea throughout. Okay, but when it comes to homeworks and quizzes, we're going to give you the numbers on the coordinate, or we're going to put the grid system where you count the numbers. We'll also show you the open circle and the filled in circle dot stuff. So what about this guy here? All right, I got to put my coordinates on here. So I'm going to say this is over here at -4. This one over here is at 3. It reaches its top point up here at 7. It reaches its bottom point down here at -7. So these will be the same points, 7, -7 down here. This was -4. This didn't quite make it as far, 3. All right, so what's my domain? Because these are filled in circles, I'm going to use brackets. Domain, I'm going to use the x-axis. That'll be between -4 and 3. Does that make sense? The range, because I actually hit this minimum point right here, and I hit this maximum point, my range would be bracket -7 to +7. I'm using my y-axis to describe the range. Does that make sense? But look at the third example I have over here. Okay? Now, on this one, I'm going to put some axes on here. Let's see, here's 1, here's 2, here's -1, here's -2. This thing meets up here at like 4. It's this particular point. Here's 5 up here. And here's -1, here's -2. Down here is -3, and way down here is -4. So I'm actually going to show you some more points than what I actually put on there, but there you go. And the range will be the same. I'm just not going to put the points on here. Here we go. Look at this graph. Look at how I label my points. And tell me what the domain is, please. What's my domain? All right, open. Got to give me some parentheses or brackets things here. Because the open circles, we don't hit these points, right? But the graph is between these two guys, so it's parentheses -2 to 2 would be what the domain is. Now look at this particular graph right here. It's the same picture. I didn't put my graphs on here. What's the range? Bracket 4. Now remember, range, you can use the y-coordinates, agreed, but you read them, when you look at the y-axis, you read it from bottom to top. On the x-axis, you read it from left to right. On the y-axis, you read it from bottom to top. So, what's on the bottom? Well, because of that open circle, you don't quite hit -3. So that would be parentheses -3. All the way up to, but you actually hit the point 4. That was your maximum point, so it would be 4 with a bracket. Does that make sense? And you have to decide whether you hit it or don't hit it. Yes, ma'am.
Why wouldn't it be like that if it was from just 4 down? Or is it just because it has those little circles, some of it has to go on that side?
It stops, that's true, but also when you're looking at your axis over here, the x-axis, these are your negative numbers, -2, -1, 0, 1, 2, and it keeps on going, right? So you read the x-axis from left to right. The y-axis is up or down. You can turn it on its side, that's fine, and we'll label them. Here is -1, -2, here's 1 and 2. But when I look at it, instead of reading it from left to right, we have to read it from bottom to top. You always read it from bottom to top. So I'm looking at the bottom. I don't hit anything, no graph, and this is where the graph starts at with open circles. So I hit it right here. So here it is at -3, and then I got graph in between -3 all the way up until this top point 4. That's why.
If it wouldn't have had like the circles on there, would it just would have been like the bracket 4 and then 10?
Two things. If it was filled in dots, it would have been a bracket -3, right, to 4. But let's say I put little arrows on this thing. What does the arrows on the graph mean? It continues. So if it continues and you got arrows going straight down, where you're going straight down, where you're going to? -infinity. But you read it from bottom to top, it'll be from -infinity with a parenthesis, -infinity up to 4 bracket. Does that make sense? So the difference between open circle, closed circle, and arrows. Okay. Also, to let you guys know, the 3 functions which most frequently have domain restrictions, which is what I was talking about before, are fractions, because you can't divide by 0, radicals, and not just any radical, even radicals, square roots, fourth roots, sixth roots, dot, dot, dot. And something else we're going to hit with you guys a little bit later on that I didn't mention, logarithms. When we get to logarithms, they're also going to have domain restrictions. You can't take the log of a negative number, nor can you take the log of 0. Function notation. All right, we use equal to example. So when we're talking about functions, you know, we like to call it something or other, but give them names. So y equals mx plus b. X is the domain, y is the range, okay? So, also, we like to use, instead of y, because we're using functional notation, we like to use this f of x, g of x stuff. You're going to be beaten to death with functional notation, not just in this class, but in Calculus 1, Calc 2, so forth, statistics, so forth and so on. All higher level math classes use functional notation. Yes, ma'am.
I have a question about the arrows thing.
Back to the arrows thing. Yes, ma'am.
How would you know whether to use parentheses or brackets on the domain?
All right, let's say I changed my problem. So let me write it down here. Let's say I had this problem, and let's put the arrows on there. Okay? And this thing is up here at 5 because I want a different function. Okay? What is the domain? What is the range? Let's talk about the domain. Well, these arrows means it keeps on going, and this thing's going to get wider and wider and wider as you keep on going farther and farther down. Right? So do I ever stop? So eventually I think this thing's going to go down this way and go down this way, but if you focus on the x-axis, everything is being covered. Because this thing is going to be getting wider and wider and wider, my domain is going to be negative infinity to infinity. But what about the range? The range is when I use the y-axis. These things are going straight down. Now, straight down represents negative infinity, but when you look at the y-axis, you have to read it from bottom to top. So I've got graph all the way down here. Because of those arrows, I got negative infinities being covered here. All the way up to 5. 5 is the top point. There's no graph up here. So my range would be negative infinity. We always use open parentheses with infinities, whether it's negative or positive, comma, to the maximum point, which is 5, and I hit that point, so I use a bracket. Does that make sense? All right. Okay. So back to notation here. We're going to be interested in functional notation here. So, and we're also talking about domain and range with a different terminology, independent and dependent variables. Because you know, X and Y are not the only letters in the universe when it comes to math. We can have T's, we can have G's, we can have W's, we can have Z's, we can have a bunch of stuff. So instead of always focusing on X is the domain, Y is the range, we'll say the independent variable is the domain, the values of the independent variable is the domain, and the values of the dependent variable is called the range. Okay? So, the reason why we like functional notation is because we get to do stuff like this. For the function, instead of calling him y, we got him a name. This sucker's called f. Welcome to f. Mr. F is called f of x is equal to 2x plus 4. What we would like to have is, what is f of 2? They're telling you to evaluate f of 2. This is the f of x notation. Whatever's inside the parentheses is what you replace x with. Since f of x was equal to 2 times x plus 4, that implies f of 2 would be 2 times 2 plus 4. Well, you can crunch that kind of a number out. What's 2 times 2? 4 plus 4 is 8. And usually we say f of x is equal to y, so you can actually read this stuff off as an ordered pair. X was 2, but your f of x, which is your y coordinate, would have been 8. But this is the stuff we're interested in, the concept of functional notation. But here's the deal. It's not just about plugging in numbers into the function. You can plug in anything you want to. So here's another problem here. Here's old Mr. f of x. He's equal to 2x plus 4. The question is, what would f of z be equal to? If f of x is 2x plus 4, what's f of z? 2z plus 4, and that is my answer. Let's keep on going. I want to know what f of t is. What's f of t going to be equal to? If Very good. If f of x is 2x plus 4, f of t would be 2t plus 4. All right, a couple more of these guys. What's f of smiley face? I don't care what's inside this parentheses. Whatever's inside this parentheses, you replace the x with in the original f of x notation. So what is my answer for f of smiley face? 2 smiley faces plus 4. Watch this one, because this is the one that kills students. What is f of x plus h? I don't care what's inside the parentheses. Whatever is inside the parentheses, you replace the original x with the f of x notation. So if f of x is 2x plus 4, what is f of x plus h? 2 times x plus h, replace x plus h with x there. 2x plus h, what? Plus 4, that's what we want. And one more, since I was talking about it. If f of x is equal to 2x plus 4, what is f of a plus b? F of a plus b would be 2 times a plus b plus 4. I mean, you can clean it up and distribute, do all kinds of stuff, but it's all about understanding the functional notation of this stuff. Whatever's inside the parentheses, I replace the x with the original f of x notation. Study this stuff. If you did not pick up your test last time, I do have it in my folder up here, and I will see you guys. Review session on Friday. If you're having some certification problems or quiz problems, and otherwise I'll see you guys on Wednesday. See you guys then. We start section 4.2 then.